For this next set of examples, we are going to be finding what are called the composition functions. It's where you take an existing function and plug it into another. You are replacing the variable with a function. Let's start with f of g of x. What I'm going to do is I'm going to take the function, hang on, g here, and I'm going to replace it where I see x in the original function f. So I'm going to have x plus 2 underneath the square root. That is being squared, and then I'm adding 1. Again, this is my new x squared plus 1. Let's simplify this a little bit. The square and the square root are going to cancel each other, so it looks like I'll just have x plus 2 here. And then if I add the 1, I'm getting x plus 3. Let's do this now in the other direction, where we're going to take g and we're going to plug f of x into it. So now I'm going in the other direction. I'm going to take this entire function and I'm going to plug it in for x in this second function. So we'll have the square root of x squared plus 1 plus 2. So again, this is our new x. I keep the structure of the original function the same. Let's see if we can simplify this at all, maybe just a little. This is x squared plus 1 plus 2, which is just x squared plus 3 underneath the radical sign. Notice that these two functions are not the same. In some cases they are, and in those cases the functions are actually inverses of one another. We'll talk about that in another section. Let's do another example. Let's start by finding f of g of x. I'm going to take this function here and I'm going to plug it in for x. So it looks like I'm going to have the absolute value of 5x plus 1. That one was easy. Going in the other direction, we'll plug f of x in for g. So this whole thing is going to go right here. So this is going to look a little bit different. This will be 5, and then we'll have the absolute value of x. And then we'll have a plus 1. Again, these two functions are not equal to each other, but this is how we would find the composition function of each of them. Here's an example that's a little bit more complicated with some fractions involved. All right, let's start with f of g of x. So this whole function is going to be plugged in for x here. So we're going to get some crazy complex fractions in this with some simplification that we're going to need to do. So let's see. I'm going to write 1 over, and then instead of x, I'm going to write 7 over x plus 6, and then I'll have a minus 6 sitting here. So again, here is g of x sitting in the place of x there. It looks like we can simplify a little bit here. I'm going to combine the negative 6 and the positive 6. So this will be 1 over 7 over x, which is the same as x over 7. When I'm dividing by a fraction, it's the same as multiplying by its reciprocal. So I can flip that fraction on the bottom upside down. Let's look at this in the other direction. Let's look at g of f of x. So now I'm going to take this whole fraction and plug it in right here. So I will have 7 over 1 over 1, x minus 6. And then we have a plus 6 here on the outside. All right, again, I said that when we are dividing by a fraction, it's the same as multiplying by the reciprocal. So what I have is 7 multiplied by x minus 6 over 1. I flip the fraction on the bottom upside down and change it to a multiplication problem. I still have this plus 6 here on the outside. So this would be 7x minus 42 plus 6, which is 7x minus 36. Again, both of these fractions are not equal to each other, and this is how we find what's called their composition functions.